So I explained that this is something like a chicken and egg games. Right? Analysis and synthesis, they need each other for doing their work, right? To analyze whether this pipe is break, we need the design first. The model itself is needed for the analysis, right? So model is given, design is given, then I can do analysis. But design for this, to design this one at the beginning, we need some performance data, right? So they need each other. So it should be iteration, right? Because it's something like chicken and egg games. Also, there is another difference is for the analysis, there is a correct answer, single correct answer. Even though we don't know the correct answer, but we know that there is only one correct answer. But for the synthesis or design, there is no single correct answer. Right? That is difference. That's why we are saying ill-structure the problem. Right? And then deduction, abduction, so interpretation of design. So analysis of design. So we can say this is deduction. So deduction is interpretation and analysis is similar. So that is translation of meaning or performance into design. Abduction. Abduction is similar to design. That is, we start from meaning or starting from required performance to arrive at converting required performance into a design, specific design. I want to design a steel pipe which is not breaking under 50 kilometer force in the middle. Right? So what can be the thickness and diameter and material? So starting from performance or meaning, arrive at a design, or starting from a meaning of a sentence, we arrive into a sentence, language sentence in Russian language. That is design or abduction. I explained it many times. So linguistic, right? Semantics. Semantics is a meaning, right? Meaning of sentence contains. Syntax is that is grammar, rules which should be satisfied. So each sentence should satisfy both of them, meaning and grammatical rules. Okay, and meaning of a design or meaning of a sentence that is hidden inside the sentence. So we should find out. Producing designs starting from performance, required performance. We want to arrive at a description. Description can be a drawing, can be a CAD model. Right? Description of this pipe. In terms of geometry and properties. That is similar to abduction. Okay? So we can use interpretive knowledge for the production of design. Yeah, we use. And so that is similar to saying the deductive system is going backward, running backward. So there has been a drawing on this. No, not is coming. Where is the drawing? Oh, here. Okay. So the interpretive knowledge. This one is interpretation. Starting from design, find out the performance of this one, right? Meaning of this one. But abduction is backwards, reverse way. Starting from meaning or starting from performance, required performance, and arrive at specific design, description of design. So we still use interpretive knowledge, but in a different reverse direction. Right? Okay. then so reasoning, once again, the same picture, same table, right? But we are talking about this abduction case. So rules, regulations, grammatical rules, and meaning, result, performance, required performance. I want to arrive at a sentence of Russian language or specific design or smartphone, smartphone for Indian ladies, young ladies, right? Specific cases. That is design or abduction. I explained several times again, right? Repeated because it's very not simple. Generative knowledge, it can be a grammar, or Lego blocks, where a sentence is a legal sentence. Whether is defined or judged by the grammatical rules, right? Legal sentence, correct sentence. So grammatical rules of syntax, similar. Parsing in compiler in programming language, compiling. We call the parsing is the first step. They do some syntactic analysis, not semantic analysis. Syntactic analysis. Whether there is a comma, space, or bracket, correct sequence, right? There's syntactic analysis. So parsing is the first step in compiler. So lexical, syntactic, and final step is semantic analysis. So you should what the meaning of that programming sequence or language contains, right? It is a if then else, or it is a do loop, or it is a branch, or something like that. So then after that we can do some work, right? Programs can do work. The rules produce description of designs conforming to the syntax of a language. So grammatical generative knowledge has been these two pictures already shown to you several times, right? Several times in this way. This is 2A, but generative knowledge. Here is interpretive knowledge, right? Interpretive knowledge. So this one we are talking about generative knowledge, grammatical rules. So grammatical rules produce description sentence conforming to the syntax of the language. Right? Question? Space of design. This is a space of design. It is defined by can be defined by generative knowledge. So it can produce any combination of Lego blocks, any combination of language, Russian language terminology, which is conforming to the rules of syntax. But we don't care about meaning at this moment. Right? So here, generative knowledge. The grammatical rules can produce correct sentence, legally correct sentence. But then after that, you should interpret that sentence or Lego assembly, whether they have some interpretation, whether this is correct meaning or performance. So we call this is a generative and test case, right? Generate and test, right? Generate and test, and then we can select feasible solutions. Lego block, natural language is concerned with the vocabularies of words, terminologies, words, count, and also rules of sentence construction. Design is also concerned with the vocabulary of elements such as parts, right? Gears, rods, and transistor, struts, and also concerned with rules, grammatical rules that dictate how these elements are put together. So we call this as a mating condition of Lego blocks. Very simple, but sometimes it is different cases of mating conditions. grammar provides a formal way of representing this knowledge mating condition about composition. Composition of a sentence. And interpretation and generation. Lego playing. So there are so many plastic parts in Lego blocks, right? Lego blocks. We can see this is as a vocabulary. And syntax of composition, there's a rule, very simple rule, plug and socket and connections, right? In Lego. Right? And then after combining, assembling only following the plug and socket connection, then we should translate into a set of design descriptions. This is a different one. The starting from meaning, objective, required performance. We want to arrive at this description, the drawing, CAD model. Sometimes it can be a complex airplane or ship or military tank. So if you are playing with a Lego block, as an adult, you may have a picture in your mind, which one I want to produce. Right? Tank, then you can select components and then Lego blocks and arrive at military tank. But as a young adult, you may not have such a process and imagination. So they just put any blocks together. Right. This is just rules, simple rules. Right? But there is a big plug and smaller ones. Only two kinds of rules, right? Here. Language and design, already told several times. Linguistics is also concerned with generating and also interpreting strings of symbols. It can be a word, it can be a sentence. Vocabulary is a parts and components. Composition, style, context, and meaning. These are components of language. Right? So there is a compositional rules, grammatical rules applicable to the configuration of components in a design or a sentence. Product structure in PDM. Have you heard about PDM? Software system, PDM? No? This is a software which is handling about product data management. So it's kind of a database management system, right? Database management system, right? PDM, data management, right? But it is specialized for product data. So engineering design data, specialized database system. And inside that, they handle product structure. Product structure, you see, very similar to assembly structure. Assembly. So that car is made of tire, engine, and chassis, brake system, and engine is made of piston and cylinder and other things, right? That kind of structure, assembly structure, we call this product structure. Arrangement of gears and pulley in a mechanical device. This is similar. And you can find similarity in language too. So language and design. So this is a parsing, natural language grammatical system. Where is it? The boy eats the apple. Right? So sentence, verb and noun phrase, nouns and verb phrase and determiner. So there is the rules of sequence, right? And then finally it arrive at sentence, right? Sentence. So parsing should be checking whether that follows grammatical rules first. Right? Syntactic check. And semantic check is coming. human language, so learning of human language takes place over a long period of time and involves trial and errors. As you may see very young boy or girl, child, how they learning language, right? Or you may learning now the Korean language now, right? You need to have a trial and errors. Right? 안녕하세요. Try this. 안녕하세요. No, this one. 안녕하세요. Right? So then trial and error. So there should be a feedback and corrections mechanism from the environment. So Korean teachers tell you that no, this way, right? And so this is very similar to induction or learning. What is this? Associative network or parsing tree. Little girl dropped red block. It's a sentence. We should analyze whether this is what is components and divide into two pieces and analyze the syntactical. So it's a comparison table between or knowledge between language and design. In language we had words and grammar and sentence and meaning. Right? In design there's parts and components and making conditions and design itself or drawing or CAD model, and then its performances. So very similarity here each one. Question. So this one, the same drawing here. So we start from required performances or meaning I want to deliver to you. And using interpretive knowledge, we arrive at some sentence or some drawing or design. Another way is just generative knowledge using grammatical rules, generate sentences, correct sentences. So hopefully we arrive at those intersection of grammatically correct and then meaningfully has a meaning, right? So generative and interpretive knowledge serve to define spaces of designs given a set of performances given or required performances. We wish to produce design that fall within the intersection of two intersections. Okay, me ice cream. It is syntactically correct? No, right? It is not syntactically correct. But it has a meaning, right? But this one they are saying. This is syntactically correct one. Colorless green, I just sleep furious. But does not have any meaning, right? So this is generative knowledge. We use just generative knowledge. But there is no meaning. This one is meaningful, but syntactically incorrect. So intersection should be that way we can explain. Both knowledge is required. So me ice cream is in this way. Me ice cream. Colorless, whether green or something is in this way. We should find out the both intersection. Design syntax. The grammatical rules. Typically, in the design of a machine, size of component may be unknown at the beginning. Size of engine, size of tire, size of seat, size of audio system, size of the display panel is not known at the beginning. Right? So, similarly, the vocabulary of available words is not always completely known at the beginning of making sentences. Especially if you are trying to make a Korean sentence, you are not you don't have enough knowledge about dictionary of Korean words, right? So we can represent generative knowledge in terms of actions for putting components together. That is another way, another working way. So we can use generative knowledge. How can you represent knowledge in terms of that can be seen as actions of putting components together, right? Words together, Lego blocks. Right? So syntax is kind of how things go together, how strings of characters may be organized. That is a logical working. Right. So the redefining the space of design. So this is design space of design, right? Well, what is the redefining? That is a changing the shape or size of the design space. That is different way. Right? Until now, we just think about making designs, single element inside space. Right? Collectively, they make a design space. But now we are thinking about how can we enlarge or shrink the design space itself. That is another way of thinking. Right? So the knowledge is this one, and this one gives you the size and scope of this space. That is decided by this knowledge. By changing this knowledge, you can redefine the space or boundary of this. That is related with knowledge in acquisition or induction. Acquisition and induction. Right. Creating knowledge, collecting more knowledge, and then spaces. Right. So think about, say, Lego block. I showed you one picture. There has been only two rules, right? Smaller and two sides of pins and locks, right? But if we include another way of connecting, say in this way, or in this way, right? That is different rules of connection, right? That includes increase of knowledge space rules. Then you can create more diverse assemblies of Lego blocks. So knowledge acquisition is very similar to induction, and so that we call this is innovative design can be done by enlarging your knowledge. So you are smarter, then you have more knowledge, then you can create more new designs, innovative designs. So we call this is innovative design. Oh, he's smart. Right? What is smart? He has more knowledge, something like similar. Knowledge acquisition. So knowledge in procedures is implicit. So inside procedure, working or activity. There are many knowledges around the world. Right? One product contains many knowledge itself. So we do reverse engineering also as a way of acquiring knowledge. But here is procedure also. Procedure is, there's a process. How can I operate a car? So operating a car, this is a kind of procedure or activities. Right? Inside that, there is also many knowledge. So design knowledge is also implicit, hidden inside, in existing designs, or design episodes, or cases, design cases. So good designs, right? Good designs. Good designs. I don't have a smartphone today. Good design. That we can, from this product, we can learn, right? Some good ideas. This way, right? Or good product, new product. So I heard that Apple will produce phone X in coming November. That contains 3D face recognition something. So by learning, seeing, or analyzing this existing new designs, you can learn new ideas. Right? Knowledge can be made explicit as a rules. Rules means there is a if-then rules. Right? If, and then rule. This is we call this a rule, right? Okay. So it's a rule. I also talk about rule base or knowledge base. Right? Knowledge base. So this class is about knowledge base. Knowledge base design. So we need to make the knowledges as explicit rules or other representation. Can be a sentence, so that we can collect them to make a knowledge base and then use them for your term project. Otherwise, you cannot use computer. All right, so knowledge acquisition is required to create your knowledge base. So knowledge-based design is we need to start from creating knowledge base first. And then we can use this one. So how can we create or produce knowledge base? Usually we start from a human expert because he has many knowledge already in his brain. So we can have an interview with him to collect his knowledges. Knowledge of his, say, 30 years of work in a factory. He has many experience and knowledge. So we collect them and convert them into digital rules or other representation, which can be stored in computer. So there is a knowledge acquisition process. Or we can say a learning process, learning. In terms of computers. Computers are learning, right? By collecting knowledges. Computers can be smarter every day. Right? Knowledge acquisition. Existing designs can be used in several ways. Existing designs. Smartphone, Google, by their simple imitation. So imitation is imitation of very famous Charles Jourdan bag, right? Imitation, imitations. As prototype. Prototype, I explained about Boeing 747 prototype. A good design, right? Or you can collect knowledge from the design, right? Smartphone or Boeing design. So we can produce knowledge base. Or we can use design as an example from which analogies can be drawn. So we call this as case-based reasoning. Case-based reasoning. Case is very important for medical doctors and lawyers, especially lawyers. Right? The main work lawyers are doing is they should find out previous similar cases. If there is a very exactly same case, then you can apply the same sentence to them. Right? Decisions. Right? This is more reasonable. Right? So case-based reasoning is that kind of one. We will see more on generalization from example. That is from learning. Say the Kepler is analyzing many cases, examples of star movement, and he generalized into a theory or equation. Right? So it's a generalization. And then we call this is a creative and knowledge acquisition, generation of knowledge. Reasoning is case-based reasoning. Interpretive knowledge is here. Right? Interpretive knowledge. So there is a way of acquisition of this knowledge is successive discrimination of attributes. I will not explain more about this. We will see that there is another method of learning. Right? So Say simply, there is a group of components. I want to make a grouping of them. So there is 1,000 of bolts, say, bolts, or Lego blocks, say, Lego blocks. 1,000 pieces of Lego blocks. I want to classify them. So how can you classify? By size, by color, by mating conditions, many ways, right? But anyway, you decide discrimination. This one is yes, this one is no, based on your decision rules, right? That kind of things. Learning through the knowledge about generalization. Kepler. So learning set within a design space as a positive and negative examples. So we call this as a negative example. This is a positive example. It's because this is a very intersection inside intersection. So good design and bad design. Or 안녕하세요, 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 right? Different cases are coming, right? So, oh, good. Say again, same way, right? This is positive examples. No, that is not good. That is negative example. So using that kind of successive discrimination or collecting good samples. So what is innovative designing? Space of design is delimited by knowledge undergoing. Right. So space of design. Right? But innovative design is sometimes here. Right? Before then, it was not a good design. But by increasing the knowledge space, right? Or somewhat differently, right? The Apple phone is very smart design, innovative design. But before then, we don't know about that kind of thing inside our design space. This is new. So it is an innovative design. So we should redefine the design space by somehow, by a person, by a rule, by a computer. So boundary is modified. Right? How? By using, by new rules, the knowledge. So knowledge defines space. Say Lego block mating conditions, only 2, but I want to increase them into 5, and then the design varieties can be increased, right? So neural network or genetic algorithm and constraint, especially neural network is related with this kind of. The TensorFlow is neural network. So creative. I think this is the final section. Prototype already. I explained this one. Schema is a very fuzzy language to you maybe. But you can say that, do you know about Oracle? Have you heard about Oracle company, right? What is Oracle company is doing? Database management system, right? So do you know about database management system? Yes? No? Simply, Oracle database is made of tables. Okay? Tables, a lot of tables. Excel files, simply. Simplified version of a database management system is set of Excel files. But there are connections, relations between them. Right? But how the tables are organized, say there is one table of Excel, the first column is name, second column is social security number, third column is phone number, right? And so I showed you Excel file, right? So who designed this one? Myself designed, or TA designed that. Format of tables, right? And there are thousands of tables, different tables. Who designed them all? And collectively, we said this is a schema of the database, right? Somebody should design the tables collectively. and then we use them collectively because they are connected to each other somehow. So we say this is a database design. And designer of database, usually the most important part is schema design. Right? Okay? Question? Okay. So it's a conceptual structure for organizing concepts in relational database tables. Exactly. Excel. Relational database. Oracle is a relational database system. Relational is another terminology you should learn. There is other way of database. Designers must begin designing before all the needed information is available. Right? At the beginning. So when I started to design a smartphone for Indian ladies, young ladies, it's assigned to you as a term project. Start now, right? But what do you have? Nothing, right? I have only assigned you the required performance, right? Nothing available. I don't know which color they like. Right? It should be surveyed first. Collect data from Google or visiting. Right? At the beginning of designing, or at the beginning of your term project, you don't have any knowledge about this. TensorFlow or smartphone. You should learn, right? Collect. Right? So needed information and knowledge is not available at the beginning. What is needed information? Is known only as you proceed your term project. You start, discuss, and find out which one we need to arrive at the term project result. Right? So as you proceed, the needed information is find out. So that is also another difficulty of designing. Boeing 747 prototype, right? Starting from one design, they just change their length. Right? The window is 5 here, 5, 4, 4, right? And also the second floor is bigger here, right? And there should be more changes, right? More changes. It looks very similar, but very big differences. So how many passengers are there? Different among them, right? Usually that is most important thing for Boeing, how many passengers we can carry, because that is money, right? Prototype, conceptual schema. So once again I say schema. For design knowledge, we call this as prototype. A class of generalized design that embeds design direction to be produced, and vocabulary, knowledge, and interpretation. So all in one, I can say all in one, right? All the components are inside prototype, collectively, right? So then we can use prototype for the refinement, for the adaptation, for the generation. So at the beginning, Boeing 477, 20 years ago, first time, or Apple smartphone started 7 years ago, 8 years ago, at the beginning. Before then, there was no such word. So we need to generate that prototype. Now, it is well known as and used for adaptation and refinement, later stage. So generation is most difficult. This disruptive innovation now, it is for land-based transportation. Right. 20,000 years ago, horse, coach, train, car. TGV, maglev is magnetic elevated boosted train, something. Magnetic levitation transportation, maglev. Very fast. They are saying 1,000 kilometers per hour or higher. prototype generation or creation. The sample coming from the textbook. So required performance is implementation of slicing egg. Slicing egg. Then they arrive at this new design of egg slice. But there is a requirement. So they started from using knife or razor, and then they combine hybriding and then find out. So this way we can generate a new. This is final slide. Summary: implicit representation of knowledge hidden inside. That is usually the existing design. Contains many knowledge inside. A generic design, general design, procedures, activities, algorithm can be a procedure. And the simplest model of designing is generate and test. That's a simple way, so you can do in this way. So computers can do well this way, where we employ our knowledge about syntax to produce designs, legally correct design, and then use interpretive knowledge to arrive at performance or meaning to interpret designs and find out the correct and meaningful intersection. And design process, we didn't cover it yet, but design process also contains knowledge itself. We call it action and control. All right? It takes time. Question? You know, we can have 10 minutes. 10 minutes. Because we should also have a term project teaming and